The aim of this project and this idea is to improve the user experience of riding an electric longboard. There are many electric longboards for sale on the market today, but almost all are controlled with a remote control or with a smartphone application. This removes the natural riding experience and gives the user a feeling that they're riding on top of a remote control car. We want the user to have a natural riding experience, which means when they lean forward or back and distribute their body weight, the skateboard will react accordingly. We do this by using a load cell to detect the rider's weight and weight distribution, and then adjusting the speed and forward motion of the skateboard accordingly. Our solution uses a load cell to sense the rider's body position. Depending on how far forward the rider leans, the load cell will measure the change in fore and aft weight bias and weight distribution and will accelerate the board accordingly. The signal from the load cell is amplified and sent to a Linux-based microcontroller, in this case a Raspberry Pi Zero, where the signal is filtered and translated to a value that is then used by the electronic speed controllers. From there, the value is sent over an I2C network to an embedded microcontroller, and in this case, that microcontroller is a Texas Instruments MSP430. The MSP430 then takes that value and uses it for the pulse width in a pulse width modulation or PWM signal to individually control each electronic speed controller or ESC. The speed controller is used to power and control a 3-phase brushless motor. In order to have enough power to move the board with the weight of a rider up to 300 pounds, two 6-cell 4,500 milliamp hour LiPos or lithium polymer batteries were selected. Each speed controller and motor is powered by their own LiPo battery. One way this project could be improved in the future is with the addition of more load cells. Right now, the design includes one load cell placed at the front axle or truck. In the future, if you added 2 load cells or even 4 load cells, 2 on the front truck, 2 on the rear truck, it would provide a more accurate reading of weight distribution, which would contribute to more accurate controls of the speed. Keeping safety as a top priority, an addition to this project would be incorporating a fuse and a safety cutoff switch. These would both be necessary if this idea were to be taken to market.